Right, hi. This is the first video in a short, uh, very short series of videos, just introducing us to the last few bits of mathematics that we need for the course. So this is our differential calculus and integral calculus. So differentiating and integrating. Um, so differentiation is a lot easier than it sounds. It is a very powerful mathematical tool. And what we really mean by differentiation is basically trying to work out what the gradient of a curve is or a gradient of a line. So just to kind of go back to something that we're a bit more familiar with, let's go back to thinking about our straight line. So if I had y is equal to 2x plus 4, so let's say this is going through 4 on the y-axis, what is the gradient of this curve? Well, hopefully you've said straight away that the gradient is 2, and we know this from our knowledge of the straight line equation. Okay, y equals mx plus c, and we know that that plus c is the y-intercept, and the gradient is m, in our case 2. So what does this actually tell us? Well, the gradient tells us how much the line varies in the y direction depending on how much it changes in the x direction. So how y changes with respect to x. And that's actually the key to differentiation and the key to the gradient. So in engineering, why is the idea of the gradient really important? It's because it links to the rate of change of a variable, how quickly something changes. Now we see this a lot in if you have a look at our equations or our concepts, this appears a lot in our engineering knowledge. So for example, uh, let's think about those Suvat equations. We've got displacement, we've got velocity, we've got acceleration. Well, what is velocity? Velocity is how quickly you move, right? How quickly your displacement changes as time changes. So it's the rate of change of displacement. So velocity is the rate of change of displacement as time changes, or we could say with respect to time. Acceleration is something similar. Acceleration is how quickly your speed changes or your velocity changes. So acceleration is similarly the rate of change of velocity with respect to, and I'm going to write a little shorthand here, WRT with respect to time. Okay, so whenever we need to look for a rate of change, it means that if we're looking at it from an algebra point of view, we might be wanting to differentiate. Okay. Now we could do this graphically as well. So if we knew that we had a straight line, we know that the gradient of a straight line is measured by the change in y divided by the change in x. If it wasn't a straight line, if we had, let's say, something that looks like this, I could work out the gradient at any point by drawing a tangent to the curve. So for example, let's say I wanted to know the gradient at this point. We could take a ruler, draw a straight line that just touches the curve at that point, and then I could work out the change, draw a triangle and do the change in y over the change in x at that point. Now we know this will change depending on where the point is. Let's say I wanted to work out the gradient over here, and there's my tangent line. I would have a completely different gradient. Okay, so for a straight line, the gradient's the same everywhere, but if it's not a straight line, if we've got a curve, the gradient changes. So we could, as we said here, graphically draw a tangent to the curve and work out the gradient. But if we know the exact equation of the curve, we could find the gradient function by differentiating. And that's what we'll look at next. So how do we differentiate something? So let's, for example, say, I'll go back to y's and x's. Let's say we've got y is equal to 4x squared. How can I work out some sort of relationship to do with the gradient? Well, just as a little idea here, for a straight line, to work out the gradient, we did the change in y over the change in x. So if we're going to do this algebraically using calculus or differentiation, we don't use change in y over change in x anymore. We use very similar notation, but it's dy over dx. Okay, so you can see that looks really similar to this. It's just that I've got d's instead of those triangles. So delta y over delta x is now dy over dx, and we need to differentiate to work out what this is. Okay,